All right, guys, here we go. So, dividing polynomials. We're kind of tracking into some new uncharted waters here. Let me get my keys. And so I'm going to kind of take you this way. We'll do these two problems real quick, and then I'm going to show you some different new things that you're going to learn, and then we'll get you going. Okay, so old dividing polynomials. So this will help you on your first couple of problems. What's the difference between this one and this one, including remainder? So if you remember, this is 14 divided by 2. So 14 divided by 2 equals 7. So all I did was divide, or really what I did is I factored this out, and I canceled one out, and then what's left? A 7. That's my answer. Now, if I do it this way, 7 times 2, these aren't the same. None of these are the same, so I can't do that. So what you've been taught in the old school way of doing this is that, and it's just a real basic idea of division. 3 goes into 14. 4 times 12 is, 4 times 3 is 12. You get a 2. So then we have a remainder of 2, right? So if this is a remainder of 2, we write it as 4 plus 2/3, because this becomes the denominator, okay? Because we're still dividing it. There's 2 left over. So what we really did on this one is we factored it out and we said, okay, well, 12 plus 2 is the same as 14, right? 14, 12 plus 2. So then what we did is, since there's a common denominator, we did 12 divided by 3 plus 2 divided by 3. What's 12 divided by 3? Well, it's 4 plus 2/3. Those are the same thing. Which is basically, we got this answer by taking how many times 3 goes into 14 with its remainder that's left over divided by 3. So there's multiple ways to look at division. Well, now we got to look at division in all those multiple ways. So if we look at this, it's like, holy smokes. This is division. This line right here means division. Well, how do I take this concept here and apply it to this? Well, one thing I want to show you is when you see this, or if you see the same exact thing multiplied by a negative exponent, don't forget that that negative exponent means it's reciprocal. So this technically would be the same type of problem. That's a division problem. So when you see this 2xy to the negative first power, that's really this quantity times this quantity to the negative 1 power, or the negative first power, which really means this quantity here in red divided by 2x. Okay? So I just wanted to kind of clarify that piece for you. Now, if we're going to look at this, this is division, but I've got nothing to divide by. It's a little crazy looking, but look what I did here. I took 14, and I split it up into 12 plus 2. Then I took the denominator that's common, and I split it out into 2 pieces. So I got 12 divided by 3 plus 2 divided by 3. Well, we can do the same thing here, to where I'm going to split these 3 out into 3 separate fractions. So we have 2x cubed y squared divided by 2xy plus, I'm going to change this color so you guys can see it, 2xy plus 3x squared y cubed divided by 2xy. Kind of doing what I did here. And then plus 4xy divided by 2xy. So I can look at each one separately. I can do 2, that disappears. X cubed divided by x. This has got a little 1 above it, so we're going to 3 minus 1, which is x squared. Y squared divided by y is going to leave us with a y, so we're good there. 3 divided by 2, that doesn't change, so that's got to stay the same. X squared divided by x. 2 minus 1 gives me 1x left. Y to the third divided by y to the first. 3 minus 1 gives me y squared. So then I've got my last one to go. 4 divided by 2 is 2. X divided by x is 1. Y divided by y is y. That is my answer. Right there. This can also be written, just so you guys know, since this is really technically over 1, this can be written as 3xy squared over 2 plus 2. So that answer here is the equivalent to simplifying this type of problem. So when you see problems like this, you're going to divide each one separately is what you're going to do. Just spread them out, make 3 different ones, and divide each one separately. That's the easiest way that I would tackle that. And don't forget that this could be 2xy times to the negative 1 power. So make sure you guys know the difference between those two. All right, let's take it one more level here. We're almost done. So, excuse me. So we're looking at some pieces here. And let's say I have this. X squared plus 5x plus 4 divided by, well actually, let's look at it this way. X plus 4 to the negative 1. So you may see a problem like that. Just know that we're going to rewrite it. It's a division problem because of this negative 1. X squared 5x plus 4 divided by x plus 4. Now, these don't go in evenly. They're kind of like, what? That doesn't work very well. So let's just kind of look at it here then. So let's do it a little differently. If I factor the top one, I get x plus 4 times x plus 1 over x plus 4. So this one here, I factored it. You can do the box method. You can do the upside down method, the big X method, whatever you want to do to factor this one if you'd like. I ended up, what times 4 adds to make 5? 4 times 1 makes 4. 4 plus 1 makes 5. That's kind of how I came up with that. So why did I do that? Remember what I did earlier, 14 over 2. I split it up into, excuse me, 7 times 2 over 2, and those canceled. Look what happens here. X plus 4 cancels with x plus 4, and I get x plus 1. Kind of cool. So that works. So it works out pretty good. Now, that's one way to look at it. Now, what happens is, sometimes, how do we deal with the idea that there may be a remainder like 14 divided by 3? Remember, that one doesn't go in evenly, and we ended up with 4 plus 2/3 because this was my remainder. Well, if we take a problem like this, x squared plus 5x plus 4, and we divide it by x minus 1, we've got a problem because this doesn't cancel out with anything because we just did that. It's x plus 4, x minus x plus 1. Those don't cancel. So there's a trick. It's called synthetic division. So this is what we're going to do. We're going to take x minus 1. We're going to set it equal to 0. So we're going to get x equals 1. So we're going to divide this whole thing by 1. So I'm going to change the colors on these. 1, 5, and 4. And then I am going to do an upside down division sign like this. And I'm going to take this x right here, I'm going to put 1 right there. Okay? Then I'm going to take the coefficients for each one, 1, 5, and 4, and I'm going to put them inside the box. 1, 5, and 4. Okay, now you may have to rewind this to kind of see what I did. Okay? This one here always comes straight down and becomes a 1. 1 times 1 is 1. 5 subtract 1 is 4. Okay? 1 times 4 is 4. That shouldn't have worked out. What the heck happened here? Hold on, guys. Let me think about this. That shouldn't have... Oh, we add the columns. Sorry. We add the columns. Add. 5 plus 1 is 6. Is that going to work out right? I hope so. 1 times 6 is 6. Add down the column. We get 10. Okay, so what we have here is we divided by x minus 1 here. And I'll go back over it again, guys. We divided by x minus 1 here. X squared divided by x gives me 1x. X divided by x, those cancel. That gives me plus 6. And this is my remainder. So my answer is x plus 6 plus 10 over x minus 1. That's my answer right there. Synthetic division. So let me walk you through that again. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. 4 plus 6 is 10. I take an x off of each one of these and I get x plus 6 plus 10 over the remainder. So this is my remainder right here. This is my remainder. Kind of like this idea here. Okay? So let's do another one just so you guys can see the pattern here. So let's do like 4x to the 4th plus 3x cubed plus x plus 1. Let's do that. And we're going to divide that by x plus 2. Okay? All right, guys. So what I want you guys to notice is a couple of things. First thing we always do is we take the denominator, x equals negative 2. Okay? And then that negative 2 is what I'm going to be dividing by, so I can just really write it like this. Okay? And remember, I got this negative 2 by saying x plus 2 equals 0. I solved for x. I'm going to take my coefficients here and put them in decreasing order. They always got to be in decreasing order. So the largest degree goes here, smallest degree goes here. So the number in front is a 4. I got x to the 4th, x to the 3rd. The number in front is a 3. Then I go to x. I'm missing x squared. So I've got to put a 0 there for no x squared. And then I have a 1 in front of the x and a 1 at the end. Okay, so let me write something here for you guys. For this particular problem, it goes x to the 4th, x cubed, x squared, x, and the constant. Okay? Look at x to the 4th, x cubed, x squared is missing, so I put a 0 there. You got to put a 0 there. It messes everything up. X, and then the constant and the constant. And all I did was I put the coefficients in front here, like this. Okay? So now, this one here always comes straight down. Okay? Now, what do I do from there? Remember the pattern. Negative 2 times 4 is negative 8. 3 plus negative 8 is negative 5. Negative 5 times negative 2 is negative 10. 0 plus negative 10 is negative 10. Negative 10 times negative 2 is positive 20. 1 plus 20 is 21. 21 times negative 2 is negative 42. 1 plus negative 42 is negative 41. Now, we have our coefficients up here. Here's our coefficients, but I divided each coefficient by x. So if I take away an x from this one, it becomes x to the third. Take an x squared, take away an x, take away an x, it's gone. There is no x. This is my remainder over the denominator. So when I rewrite this, it's 4x cubed minus 5x squared minus 10x plus 21 plus negative 41 over x plus 2. All right, guys? This is called synthetic division, and this is how we divide things that we can't divide. Just like dividing something like 5,327 divided by 23. We have a certain pattern we follow. Same thing here. Set x equal to 0, the denominator equal to 0. Find out what x you're dividing by. Take the coefficients of each one in decreasing order of power. X to the fourth, x to the third, x squared, x, and the constant. Remember, if you're missing a power, you just write 0 in there, because we're missing a power right here. Then we put them up there, 4, 3, 0, 1, 0. Pattern. Bring the 4 down immediately. 4 times negative 2 is negative 8. 3 plus negative 8 is negative 5. Negative 5 times negative 2. Oh, I messed up right there. See, this is why you go back over your work. This is going to be a positive 10. This is a positive 10. This would be a negative 20. This is a negative 19. Yeah, because 2 times that is negative 20. That's negative 19. This is a positive 38. This is a positive 39. There we go. So that changes this to negative 5, positive 10x, minus 19, plus 39. So just like everybody else, got to make math mistakes. So let's go through it again just to make sure. 4 times negative 2 is negative 8. Get the negative 5. Negative 5 times negative 2 is positive 10. 10 times negative 2 is negative 20. Negative 20 plus 1 is negative 19. That becomes positive 38. 38 plus 1 is 39. So yeah, my math is good now. All right, guys, synthetic division. Here we go. That's all we got. Let's make it happen.